Have you ever wondered what it would feel like to travel at the speed of light? Imagine hopping into a spaceship, blasting off from Earth, and zipping across the galaxy so fast that planets blur into streaks and time itself begins to warp. Sounds like science fiction, right? Well, here's the crazy part. It's not entirely fiction, but could we actually do it? Let's start with what the speed of light really means. Light zips through space at an incredible 299,792 kilometers per second. That's nearly 300,000 kilometers every single second. If you could travel that fast, you'd circle the Earth about 7.5 times in just 1 second. And if you were headed to the Moon, you'd be there in just over a second. Mars, a few minutes. And the nearest star system, Alpha Centauri, you'd get there in just over 4 years. So the big question is, could a human, or even a spacecraft, ever reach that kind of speed? According to what we know from Einstein's theory of relativity, the answer is no, not exactly. Here's why. As something with mass, like you, me, or a spaceship, accelerates and gets closer to the speed of light, it needs more and more energy to keep speeding up. The faster you go, the more energy it takes. And as you approach the speed of light, the energy you'd need shoots up toward infinity. That's right, to hit the actual speed of light, you'd need infinite energy. And last time we checked, infinite energy is not exactly something you can pick up at the gas station. But it gets weirder. As you speed up, your mass also increases. Not your weight. That's just how heavy you feel under gravity. But your actual mass, as in the stuff you're made of. Get close enough to light speed, and your mass becomes enormous, like a moving black hole. That's why light can travel so fast. It has no mass. For light, speeding through space at 299,192 kilometers per second is just its natural state. Okay, so if we can't actually reach the speed of light, could we maybe get close? Like really, really close? Well, scientists have already done that. Not with people, but with particles. At places like CERN in Switzerland, giant machines called particle accelerators can launch tiny particles, like protons, to more than 99.99999% the speed of light. At those speeds, some seriously strange things start to happen. One of those things is time dilation. That means time actually slows down for something moving close to the speed of light. If you were flying through space at, say, 99.9999% light speed, you might experience just a few days of travel while years passed by back on Earth. It's not just science fiction. It's been proven with atomic clocks flown on airplanes and satellites. Time really does stretch and bend, depending on how fast you're moving. This leads to an almost mind-blowing idea. While we might never reach the speed of light, if we got close enough, we could effectively time travel into the future. Want to see what Earth looks like in the year 3000? If we could build a ship fast enough, you might leave today and arrive a few days later. But for Earth, hundreds of years would have gone by. Still, building such a ship is a gigantic challenge. Let's say we tried to use rockets. The problem? Our best rockets, like the ones that took astronauts to the moon, are way too slow. Even the fastest spacecraft humans have ever built, the Parker Solar Probe, only travels at about 0.05% the speed of light, and that's when it's being pulled by the sun's gravity. To go faster, we'd need entirely new kinds of propulsion. Things like antimatter engines, nuclear fusion, or even giant solar sails pushed by lasers. These ideas sound wild, and they are, but scientists are already experimenting with early versions of them. There's even a project called Breakthrough Starshot that wants to send tiny probes to another star at 20% the speed of light using powerful lasers from Earth. If it works, they could reach Alpha Centauri in about 20 years. But there's still one huge problem. Space isn't empty. Even at the edge of the solar system, there are tiny bits of dust and particles floating around. And when you're moving close to light speed, even hitting a single grain of sand would be like getting smashed by a bullet or a bomb. At those speeds, space itself becomes dangerous. So, where does that leave us? For now, traveling at the actual speed of light is impossible. But getting close, like 10%, 20%, maybe even 50%, is a different story. It would still take incredible engineering, new physics breakthroughs, and probably a lot of time, but it's not totally off the table. The exciting part is we're already taking the first steps. Every time we launch a new probe, build a better engine, or test a new propulsion method, we're getting closer to making ultra-fast space travel a reality. And maybe one day, someone watching this video will be the engineer, physicist, or astronaut who helps us cross that next great boundary, not by becoming light, but by racing alongside it, chasing the limits of what's possible. Until then, we'll keep dreaming, keep building, and keep looking up, because the stars are still out there, just waiting for us to catch up.
Hey there, if you're enjoying this video and appreciate the effort behind it, don't forget to like this video. It really helps the channel grow, and if you haven't already, hit that subscribe button and turn on the notifications so you never miss an update. Oh, and one more thing, share this video with your friends. Spread the love and support. Alright, now let's get back to the video. Let me know if you want any tweaks.